Do not try this at home. The voltages used in the following experiments can cause serious harm or death. Hi guys, welcome to the video. Today we're going to be talking about spark gaps and the relationship between electrode distance and voltage breakdown in air, water and wood. This is a Jacobs ladder. It's powered by a neon transformer 15 kilovolt, and I'm going to talk to you about how the discharge actually occurs. You have two types of materials, conductors and insulators. In conductors, like metal, one or more negatively charged electrons in each atom are free to move about. This is what we call a low resistivity, and it makes them good conductors. Insulators' electrons are tightly bound to the atoms and therefore have a high resistivity and don't carry charge very well. Although, as voltage goes up, the electric field strength goes up, and if a strong enough electric field is applied, all insulators become conductors. This characteristic is called the dielectric strength and is measured in volts per centimeter. The point at which this happens is called electrical breakdown. At this point, electrons are pulled from the insulator's molecules and ionized. The electrons are then accelerated by the field and strike other atoms, creating more free electrons and ions in a chain reaction until the field exceeds the material's dielectric strength and a conductive path extends from positive to negative. The distance at which this occurs is called the breakdown voltage. Okay, playtime's over. The first experiment I did was the air gap test. So basically started at 1mm gaps between the electrodes. Now I'm using needle electrodes here. They're zinc plated screws. And I increased the gap distance at increments of 1mm at a time until it didn't discharge anymore. And then that gave me the maximum distance at 15 kV. Actually got some pretty surprising results with this, and I found out that the spherical electrodes require much higher voltage to jump the gap, whereas needle electrodes, it worked out to about 73% less voltage than the spherical. Right, so by the end of it, ended up with a maximum gap distance of nearly 2 centimeters. Now the usual for spherical electrodes, the usual dielectric strength, I suppose, is 3,000 volts per millimeter. With the needle probes, it ended up being closer to 800 volts per millimeter. This goes against everything I learnt in trade school.
Yeah.
So this is where I realised that the breakdown voltage, as far as establishing a plasma arc in water, is a lot higher than 15 kV. So I had to adjust my experiment a little bit here. This is not the result I was looking for. I thought I was going to get voltage lighting through the water. So I had to adjust my experiment. Basically took it into the bathroom because I needed the extra room, and I kept one probe in the water, had the other probe at the maximum air gap that I measured earlier, and basically was arcing to the water. I had the horizontal distance within a millimeter of each other and extended that. As I extended that, I had to bring the probe that was out of the water down towards to maintain the arc, and eventually got to a point where the arc was no longer jumping to the water, and that was at 1.2 meters. So basically turns out the resistance of the water was dropping the gap distance over the horizontal distance. The final test I did was the gap distance with wood. So basically I had a piece of wood, I had an original 30 centimeter gap with 1 centimeter intervals, and basically started pulling it in closer and closer. The first result, as you can see here, it started arcing and then stopped. The only thing I can think is that the moisture in the wood started the process, but you'll see it kind of didn't do anything for a while after this little bit. There you go. This footage here is just from earlier wood tests before I made the experiment. So it was found in wood that the maximum gap between the electrodes before it would conduct was greater than the air gap. It's probably due to the higher dielectric strength of wood being greater than air, and meant that the gap was greater. So my aim of the experiment was basically to see in the different materials whether the gap distance would either increase or decrease, and it's shown that in the water it definitely increased as far as gap distance. With the plasma charge, I'd have to redo experiments with high voltage levels. With the wood, it definitely increased, and that's all in line with the dielectric constants that are pretty well known.
Oh, my precious.